measure. But here we go. So you can kind of see behind me, what you're looking at here is the electrical. We got to finish it. But I think once it's done, what you're going to see is this trough here is all our branch circuits throughout the building. Those are all the different branch circuits, are just, just how we would explain anything that goes out and picks up a bathroom or a refrigerator or whatever. That's your branch wiring. Everything that is wired throughout the building is your branch wiring. And then what you're going to see is, let's just jump over here. I'm going to show you more than this. This isn't necessarily an electrical video. This is about too much stuff in a tiny little space. And it's really for all tradesmen who have ever wanted to go ahead and go meet the engineer and then beat them with the plans that they made. It's plans, it's paper, shouldn't hurt too bad, but maybe they'd get the picture to go ahead and look at the other portions of the plans, look at the architectural and the structural design, and look at the mechanical, look at the electrical and the electrical guys, look at so on and so forth. Because you know who ends up having to deal with this? Those of us who are in the field. And, my job should be, and I've always said this, if you're doing commercial work, is essentially, I'm just supposed to go in and decorate the cake. The ingredients are supposedly, put together by the engineer. And I'm a cake decorator when it comes to commercial work. I have been doing electrical work for well over 20 years, and have done plenty of design build. Now, design build is different. That's me coming up with the ingredients, and really, all we get is kind of what kind of cake they want, and then we come up with, the ingredients and how to decorate it. Commercial, though, industrial, with a set of designed plans like this job, I'm supposed to just decorate the cake and which is, put the ingredients that somebody else has told me to put in, and make the cake and decorate it, and that's all I'm doing. But what happens on this job? Oh my gosh, they made it impossible. We had to redesign so much of it, and had to redo and think, and kind of just lots of time with the other trades, figuring out how, and coordinating, where our stuff's going to go and where their stuff's going to go, and really it comes down to the mechanical guys, because much they're you just look at. These mechanical, the ductwork coming in, and we knew this was going to be there, and I knew I had to put all this here, and it actually showed those pipes coming right down through here, and they're just wouldn't, that obviously, I'm not going to be able to put any of my electrical stuff in here, and maybe in hindsight we should have told them to do that and just had somebody come in and build us another wall or something. I don't know, maybe there's no good way to do this, and everything had to be in this room because it's a fire-rated room. The ceiling is fire-rated. So let's see here. Let's take a look at this. What we got is a panel. I think it's 400 amp panel, and it's feeding everything mechanical in the building, and also the other apartments, the other panels in the building were fed from it. We have a surge protector here, and we have a lighting control panel, which allows us to control all the lighting throughout the whole place, and using whatever means that they want to control, dim, turn on, turn off, all that stuff. We can basically use that to do anything we want with the lighting, with some programming here at the lighting control panel. We've got a NAC panel, which this is all your notification, essentially all those loud, stupid horn strobes you hear when the fire alarm goes off. This is the panel in which they come out of. This is the main control, fire alarm control panel. As you can see, its job is basically to tell this one to go off, and that is done through a pull station, which will be here, or a smoke detector, which will be right there, or in fact the sprinkler system, if it goes off, it too will set off the fire alarm control panel. That's this. This is just some extra auxiliary power, because this panel didn't have enough power built into it to feed all the low voltage fire alarm devices throughout the building. So we had to put in a secondary source of power, so it's just auxiliary power. As you can see, we've got the wireway, we got the surge protector, everything's nippled down into the panel. We've got a little ways to go before this is done, and we'll do one last video when we're done and show you how it all comes out. But I do think this I wish I could kind of get you a better picture to kind of show you, but it is actually going to be, once we get it all wired up and covers on it, you know, it's going to be a really nice, clean job, I think. That across the way you're looking at there, I don't know if I can zoom it in. That's not my work. That's the control companies. And she came in and she's got thousands and thousands of feet of low voltage wire in here. And her job is to basically automate, you know, automate or to control everything. So it is automatically comes on and off and up and down, ramps up, ramps down, whether it's heat or ventilation, equipment, all that stuff is controlled through that over there, which also, when she's done, there'll be a place to plug in a laptop, and then they use the laptop to program all the set points. There's the hot water tank that they barely got that one to fit, right? I don't know if you can see the top there, but not a lot of space. So here we are. This is what we got going on. Let's just jump over here just real quick. Want to see if we can look at kind of showcase a little bit of the plumbing. It's really hard, sorry. The plumbing work, and just the only reason I want to kind of showcase this is because I want people to see one thing about this system is, first and foremost, it's copper. It's not plastic, it's not PEX, it's copper. And hopefully in an exposed mechanical room, that's what you're looking at. If you're looking, you go into the mechanical space and what you're looking at is all piping and PVC. I'm gonna say that you know, it probably saved you a lot of money. But at the end of the day, most plumbers who are respectable plumbers who have a good reputation in an exposed boiler room are not running PEX or anything. They're running copper. But what they are doing a lot of times now is they're using crimping technology that, you know, you put your fitting in the crimping tool, and instead of having to sweat it or solder, whatever you want to call it, it crimps from the fitting to the pipe, or whatever the case may be. And that tool, those tools are really expensive, but the idea is it's super fast to make each joint, and you save so much time when you go throughout a building crimping compared to sweating and soldering. But this guy, decide, and their company, who's a reputable big company, they're going to stick with the solder, and the reason is they believe between the fittings you have to buy and the tool that you have to buy, that they're just financially, soldering while it takes longer is still a better option financially for the customer. I don't know. I'm not a plumber, and I have a lot of plumbers we work with, and I would say that these guys are in the minority in that kind of thinking. But leave me a comment what you have been seeing other plumbers do, and what your thoughts are on that. If you're a plumber, let me know what you're doing with that. These are circulators that are built in. They're variable frequency drives that are built right into them. So they ramp up power up and down depending on the outside temperature and other parameters that are set up by the control people, like I just showed you over on the control panel wall. Just real quick, let's just go here. Here's what the existing basement looks like. Let me flip you around here. All right, so here's the existing basement. It's a mess. This is all going to stay like this with the exposed ceiling and insulation. We're staging multiple different subcontractors down here, so as you can see, it's just a mess anywhere you look. But the working space is miserable, right? I mean, just absolutely miserable. This whole job, the lighting with these phones, it's so hard to try to find a spot where you can actually not... the lighting isn't kind of just screwing everything up. But look at this space. Like, I can't explain to you how many times everybody here has hit their head. I'm guessing if there was a jar and we put $1 in it, every time you hit your head on something, that jar right now would be full of holes, because you can't help but hit your head. Let's look at one last thing over here. Let's look at the sprinkler, the phone flip. So this is our sprinkler. The sprinkler guys come in here, they put this system in, and basically what we do is we monitor it like that. It's called the sprinkler tree, And so every time you watch a movie and you see where they set off the sprinkler system, and next thing you know, the building is raining water inside it, and the alarms are going off, and all the sprinkler heads are going off. Just let me tell you, it never will happen like that. Those heads are set so that only essentially that one head has a heat sensing device in it, or fuse, and when that fuse gets hot enough and breaks, water rains out of the head, that one head, not all the heads, one head, and it will continue to blow water out of that head until somebody shows up and literally shuts down the city water coming into it. But those things are designed to dump and dump and dump until somebody comes and fixes it. And only what sets off the rest of the devices is heat and fire or whatever on each head, and it's going to set off the next head. Let's just flip you around one last time. First floor, here we are. We're kind of getting down through it. So let's get upstairs and show you the progress up here. Looks like, so we've got paint on the walls. Here's some fire alarm devices going in. Lights are in. I'm looking for countertops still. But you can see switches are in, devices are in. We are definitely getting there. With this project is kind of coming to a close. So as is, fortunately for those guys that are watching this video, let's just wrap it up. For those guys like me who are in the trades, who are just frustrated with the engineers, leave me a comment, hit subscribe, let me know what you thought of our video, let you know what you thought of the space, tell me where you think that we could have done different things, especially for electricians. One thing we're better at than doing electrical work is critiquing other electricians' work and the things that we see that are wrong with it. It's really one of my favorite pastimes in this is when we go out with friends, family, I look up, look at the electrical, and then I pick it apart and say, "Gosh, that's not how I do it." Let me know how you'd have done some of the things that you saw. Let me know what kind of questions you've got. Hit subscribe, and let me know if you think I should do more videos when it comes to construction and electrical work. Is what I do, but in general, we can do all kinds of different thoughts on and different videos on construction. Let me know what you think. Y'all have a good one.